Martha, unmute. Okay, Denise. Denise, unmute. Okay, Martha. Please, if I ask you to unmute, and we move on.
Even it was just the handing in of the work.
Handing in the work. Did you hand in or you failed completely?
I handed in.
How come that your name I'm seeing there, Martha, senior 1A?
Yes, that's just my stream, but I handed in as such a Martha Precious.
I mean, when I check, when I see your name, the name I'm seeing such Martha, senior 1A. Are you by any chance in senior 1A?
No, that's just my school's class stream, but I handed in as such a Martha Precious.
So, in other words, you are in senior 2.
No.
And we are now in senior 2. This is senior 2 class.
Okay.
Because we might start talking of things you've never had before, and you get headache. So there is a senior 1 lesson going on right now. You can check on a timetable, then you log into that class. Thank you. Irene, you have disappeared. Okay, this one I can't pronounce your name. Your name is hard. But you can unmute. I think Miss Ghana, something like that. Hurry up, and we move on. We want to do corrections. As we hear the challenges, most of us should be getting our work ready where we did the assignment. Yes, go on.
Yes, teacher. For me, the exam was good. Hello, teacher. Excuse me.
There was what?
For me, it was good.
I
handed it on time. It was good for me.
Thank you so much. Irene?
Teacher, I was saying that yesterday I tried to hand in my math paper. No, sorry, on the day we did the math paper, I tried to hand in, but I failed because they weren't showing me the exam.
How about when you were handing in the chemistry paper?
Yes, I handed in the chemistry paper.
Yeah, thank you. So, are you aware that we are in the chemistry lesson? We have a chemistry lesson. Members, once again, we're in chemistry lesson in case you have forgotten. And this is senior 2. It has no stream, so don't say I'm in senior 2, A, B, or C. This is just senior 2. Okay, Denise. We have 2 minutes to finish to say out our challenges.
Yeah, teacher, your volume is too low.
Okay. Let me see what I can do. Thank you. Okay. So it seems our problems, our challenges are very few. So as you heard, most of us had a problem with handing in the work, and I hope even my supervisors had that. So next time we shall make sure that everyone knows how to do that. Given that we have a WhatsApp group, you can easily share. You can easily share the experience. Those who handed in, those who never had any challenges, they can help you out. As you also reach to teachers. And also request that those ones without the names, put the names so that you can either be identified. Like someone with a Nokia 1, I think it is 1.4 Nokia. I don't think that we have a robot here called Nokia. Alright, so today we shall do the corrections. Get your paper ready. Whether you have handed in or not, just get your paper ready. We shall go through it together. Yes, Faith. Faith. Faith, Faith. Faith, your hand is up and you have unmuted. Faith, unmute and say what you have to say. In case you are not hearing me, it could be your network. This is the same volume I've always used and people have always heard me. No matter what I've seen your message. Maybe if it is different. Someone is asking which lesson is this? This is chemistry. Let us always check on a timetable very well. Alright, let's go for corrections. I'm trying to get my copy so that I can share with you as we do the corrections. So as I look for my paper, you should also be looking for yours. As this, I can see your hand up. You are welcome to class. So all of us, by now you should be having the work, because I've also got mine. So that is our work, it is opening. Are we all there? So we are going to start with number one. Number one is we say that carbon has an atomic number of 6. So wanted that we state the electronic configuration. That was Roman 1. Then Roman 2, we state the periods. Roman 3, we state the other group. So who can give us the answer for number 1? Who can give us the answer for number 1? Let's be first. This paper was the simplest of all. Yes, Sanu? Sanu, please. If I say unmute, unmute very fast.
The electronic configuration is 2 to 4.
The electronic configuration is 2 to 4.
Yes. The period is 2.
The period
then
is
the
2.
group is yes.
And the group is
4.
Okay, thank you. You can mute. Okay. So she's saying that the electronic configuration, it is 2 to 4. Let me use a different color. We can use red. 2 to 4. Okay. Then the period she's saying it is period 2. Then the group she's saying it is group 4. Remember, when we are writing the group, we write in Roman numerals. We write in Roman numerals. So that's why I'm saying group 4, I5. I hope all of us remember the Roman numerals we learned in P7, P5 there. So what I'll put in red, those are our answers. Okay, then next number, give a reason why carbon is in the group you have stated above in A Roman 3. So one, the reason is why our carbon is in group 4. We can have another person. Let me see. I'm looking for a male creature. Oh yeah, the gentleman. You are sleeping. Gentlemen, the ladies are taking over. Yes, Henry?
Sir, if you look at the electronic configuration of carbon is 2 to 4. That's
Yes.
so always the first digit always stands for the period, and the second digit always stands for the group. So therefore, according to that, carbon is in group 4.
Carbon is in group 4.
4.
Can you phrase it better? There's something missing. The answer is okay, but you phrase it better to be so direct to others. Thank you for that. Thank you for that. Can you phrase it, or we can ask another person?
I need help there.
Okay, your answer is okay, but it is lacking a few things. Some birungo is missing. I thought I would get a gentleman to help you, but it seems the gentlemen are busy. Let's have Lydia. Lydia, how can you make the answer better?
Carbon is in group 4 because it has a valency of 4.
Because it has valency of 4. Thank you. So you are bringing the concept of valency. If you are defining a valency before we proceed, now we can first define what is valency. So that we very fast before we proceed, who can define for us a valency? What is a valency? A valency, Grace. Sorry, I tapped on Edgar. Yes? What is a valence before we proceed? Some new term has come in. Muhammad. There is someone who is not.
Sir, yeah, I have the answer for party B.
Okay, you tell us. It's fine.
Carbon. It is group 4 because it has 4 electrons in its outermost shell.
It is in group 4 because it has 4 electrons in its shell.
Outermost shell.
Thank you so much. So members, whenever we are looking for the group of any element, we consider the number of electrons in the outermost shell. That word outermost must be there because we only consider those electrons in the outermost or the very last shell. At times we can call it energy level. So that's why we say carbon, for this case, having 4 electrons in its outermost shell, it qualifies to be in group 4. So we say this is because carbon has 4 electrons in its outermost shell. We can call it energy level. Energy level, it also means the same. Okay, so before, as I said, let's now look at, let me make it bold so that we can all see it well. Then now we can define valency. It is something good. Someone is also saying that instead of using a shell or energy level, we can also use quantum level. So yeah, we can also use quantum level. People know chemistry here. Quantum level. Okay, but you can choose the one which is simple for you. So let's define valency, because we want also confirm whether the answer that we were given was true or was correct. Valency. We can have Victoria. Victoria, what is a valency?
Valence is the combining power of an element.
Valency is the combining power of an element. Thank you. Another option, an alternative. Apart from that, how can we define valency? Lydia, I'm wondering why you are not muted, yet you are not giving us the answer. We can have Sanyu. Sanyu, unmute.
Sami, I had an answer for part B.
For part
Though
B. Do you have a different answer from what we have?
No, I only have, because its outermost energy cell has 4. Shell
Okay.
has 4.
Okay, thank you. So to save time, we can define a valency. Apart from saying combining power, we can say that a valency is the number of electrons. The number of electrons gained or lost by an atom. The number of electrons gained or lost by an atom to form an ion. Because normally the valence depends on how many electrons that you've lost or you've gained. Okay. So when we bring the valence knowledge to determining the group, you see it doesn't work, it doesn't apply, because here we are losing or gaining. And remember, this time we are considering the number of electrons in the outermost shell for a given atom before losing or gaining the electrons. So we are dealing with a neutral atom which has got the same number of protons and also the same number of electrons. Okay. Someone is saying I should pick her. Raise up your hand. Don't say that I have a grudge against you. Yes, please.
On number 1B,
Yes,
I have
please.
another answer, but I want to know if it's correct or wrong.
You share with us.
Its carbon has much higher melting points and boiling points than elements in group 13. Is it wrong or correct?
What you said, the statement might be correct, but if you are to bring it the question we have, it is wrong.
Okay.
Yes, what you've given is just a property. It is a property, not a reason as why it is in group 4. Thank you for that.
Okay.
Denise, do you have something hot that we can't live without? Okay.
No, teacher, I just forgot to lower my hand.
Okay, sorry about that. Alright, so we can continue. Number 2, define the following terms. 1, we have what we call entropy. Then 2, we have what we call outdrops. Then we have part B. So let's first define what is entropy. What is entropy? Who can tell us what is entropy? I'm seeing very few hands. Okay, Joshua?
Yes.
Define for us allotropy.
Allotropy is the existence of an element in different forms in the same physical state.
It is the existence
of an element in different forms. In different forms.
In different forms.
In the same physical state. In the same physical state. In its same
physical
state.
In the same physical state. Is that what you mean? Entropy is the existence of an element in different forms in the same physical state. Thank you. Anybody with a different answer? Anybody with a different answer? So I think we have this this definition in our notes if you are to check. You see some hands, seems people have different answers. Edgar's. Edgar's, please unmute. Edgar's. Okay, we can have I'm seeing other people here. We can have Arafa. Okay, it seems we don't have different answers. So we are defining entropy as the existence of an element in different forms but in the same physical state. So when you don't want to use the word different, you can use the word various. So here we can put the word various. So that one can also work. Okay, now we go to aerodrops. Members, if I say unmute and you take long, it means that I have to move on. Number 2. Number 2, please talk to us. The chance is gone. We can have other people. Let's have Joyce. Joyce.
Yes, teacher.
What is your answer?
Outdrops are various forms in which an element exists without change in physical state.
Okay, you are saying that outdrops are various forms
in which an element
can
exist.
Continue. I want to be hearing as I write.
Various forms in
Can
which
exist.
element exist without change in physical state.
Without change in physical state. Thank you. I hope members you're writing these things. So we need to know the difference between entropy and outdrops. We are saying that entropy is the existence. This word existence, it's like a big thing. Existence, it's like a process, kinda. It is bigger than outdrops. It is from entropy that we get the outdrops. So when we are defining, we need to put this word existence. When we are defining entropy, it must be existence. And again, those different forms must be in the same physical state. They must be in the same physical state. The moment they are in different state, then it becomes wrong. Then again, what I've seen, most of you who were defining entropy, you are forgetting that they have to remain the same physical state. That's what we mean when we say without physical state. That's what we meant. Most of us were forgetting that. And again, the word various we can use different. So there can be different forms in which an element can exist without change in physical state. It is as short as that. It is as short as that. Now what I've seen you answer in the chat. Thank you. So we continue. If there are no questions so far concerning what we have just so far corrected, we can continue. So part B, state the two crystalline outdrops of carbon. State the two crystalline outdrops of carbon. We want just two crystalline outdrops, meaning that there are chances that others are not crystalline. We can have let me see, Resty.
Diamond.
We have diamond. Thank you. Then we can have praise. Praise. Praise, we didn't hear. Okay, graphite. Thank you. You can mute yourself, praise.
Graphite.
Yes, we've had graphite. So we are saying that we have one. We have diamond. Then secondly, we have graphite. So members, those are the two crystalline outdrops of carbon. There are only two. Remember, we have three outdrops. We have diamond, graphite, and amorphous carbon. So here we are having diamond and graphite. They are the only two crystalline outdrops of carbon. We mean they are in the form of crystals. So some people are saying that I should choose them, but the problem is that whenever I say unmute, you take long to unmute, and when you do that, because of time, I have to move on and choose another person. Because all of us, we are many, and we are around 65, so we need to be very fast so that we can be in time. But next time I will choose you. So Maria, you had given us the answers. That is diamond and graphite. Thank you. We continue. Let me first put this one in bold so that it can be clear. Then there is ionus the later. I mean, I can't read this word. Maybe you can raise up your hand. Raise up your hand and I choose it so that we can pronounce that word well. Raise up your hand so that you can pronounce the word. Yes, Joanita, which word is that?
Ionus delete.
I beg your pardon?
Ionus delete.
Okay, so it is also another outdrop of carbon.
Yes.
Okay, thank you. Thank you for that information. I was not aware of that. I'll also make a research and see. But apparently, let's go with the simple ones. Apparently, let's go with diamond and graphite, the ones which are simple as per now, but it doesn't stop you from making more research and getting to know more. Thank you. Then we go to write down two properties of one of the outdrops stated above in B Roman 1. So here we wanted you to choose one. Choose one outdrop. For example, would you choose graphite or would you choose diamond? You first state the outdrop you have chosen. Then you give its properties. And for revision purposes, we can state as many as we can. So yeah, I'm seeing two people in one. Yes, Denise. Someone is saying the diamond is transparent, sparkling, and glitters. That is Maria. Maria Whitney. Yeah, Denise, talk to us.
Teacher,
Yes, please.
elements, graphite.
Yes, please.
Graphite conducts electricity.
Okay.
Since it has free mobile electrons, it is also opaque and dark.
Okay. Let's give more examples. Do you have more? More properties?
Maybe for no, teacher.
Okay, thank you. So Denise is saying that for her she chose she chose graphite. She chose graphite. And she's saying that it conducts electricity. It conducts electricity. Then she said that it's also opaque. It is opaque. Opaque means that it can't be seen through. Another one. Let's now since we have chosen graphite, we can first exhaust the graphite, then we move on. What is the other property apart from the ones we have on the screen? Arinda?
It has a high melting point.
It has a higher melting point, thank you. So it has a high melting point. Another one. Oh yeah, my boys, where are you? As I've always said, these things are on record. You know, they are on YouTube, and YouTube can keep this record for like 100 years. We shall show your kids, your children. You see, your father one time he was learning online and didn't give us any answer. For example, if I said Agaba, let me choose a boy. Beckham, what do you think? Beckham, unmute and tell us the answer, or else we keep that record that you just kept quiet. Beckham? Beckham has disappeared. Okay, yes, Joshua. Joshua, thank you for saving us.
Yes. Yes, Chair. Graphite has a giant atomic structure.
It has a giant atomic structure. It has a giant atomic structure. What is the melting point? It has a melting point of what? A density of what? It has a density a density of, let me check in the chat, that one I want to check in the chat and see. Graphite has a density of Beckham, I don't agree with you. Saying you have issues with the network. It has a density of someone saying 2.5. Is it 2.5? Someone is saying it has a density of 2.5, 2.3. So it has a density of 2.3 grams per centimeter cubed. And so on. So in your free time you can look for other properties. I remember out of these we needed only 2. So you can look for other properties if you chose. If you chose diamond, then you have also different properties. For example, where we say graphite conducts electricity, diamond does not. Where we say graphite is opaque, the other one is transparent, like that. So let's move to the next number. We move to the part C. State the non-crystalline aerodrop of carbon. State the non-aerodrop of carbon. Let me see. We can have, let me see, we can have I almost chose myself. I was going to say out my name. We can have, there is some, yes. I thought Angelica, the hand was up. Let's have Kardashian, another Kardashian.
Graphene.
We have, sorry?
Graphene.
Graphene. Okay, thank you. She's saying graphene.
Yes.
Thank you. Another one? Yes, Namatovu.
Amorphous carbon.
We have amorphous carbon. Members, however much we are doing more research, let us try to use the simplest language. Let us use the simplest language so that we can understand. So we are having amorphous carbon. We are having amorphous carbon. Amorphous carbon. Okay. So under amorphous carbon, we have other examples. We have different examples under amorphous carbon, as we shall see in the last question, I think. Then we look at also, we got number 3. State 4 differences between graphite and diamond. State. So give us one difference. We continue. Yes, Martina.
Graphite is soft while diamond is very hard.
Graphite is soft while diamond is very hard. Let me first put a table. Let us demonstrate our answer in terms of a table. Let's put a table. it needs so yeah, we can have then here we can have graphite. Okay, so can you repeat your answer? Who was it? Was it Jovia? Seems I've forgotten. Okay, we can have a Jovia.
Graphite is hard while diamond is hard while graphite is slippery.
So that one is hard, this one is slippery. Or let's use the word soft. Let's use the word soft. Number 2. A second. Let me check in the chat. Someone is saying that is Brian Crystal. Diamond is transparent while graphite is opaque. Thank you. So this one is transparent. This one is opaque. Thirdly, another person. We can have seems I'm having the same hands up. Joshua, the good thing we have spectators who are seeing us give answers. Joshua?
Yes.
Give us the answer.
Yes, teacher.
Yes, we are waiting for the answer. The difference between graphite and diamond.
Graphite is not diamond is resistant to Graphite is not resistant to chemical attacks, while
yes,
graphite is not resistant to chemical attacks, while diamond is resistant to chemical attacks.
Thank you. But given that all of them are, all of them are made of carbon, they might be resistant to chemical attack because they have the same chemical properties. So thank you for that. When I check in Brian Crystal once again, she is saying, I don't know whether you are a girl or a boy, so sorry if I call you she when you are he, you forgive me. Graphite conducts electricity, while diamond does not conduct electricity. The same answer was given by Joyce. Okay, let's put that. Diamond. Now when you're teaching a bright class, you don't use a lot of energy. Diamond does not conduct electricity, whereas graphite conducts electricity. Conducts, I don't think this is the right word. Spelling. Conducts electricity. So the reason is that diamond conducts electricity because of having those mobile electrons, which are not in diamond. Any other? Yes, Miss Ghana, I don't know what is the right pronunciation. Is saying that diamond has a density of 3.5 grams per centimeter cubed, while graphite has 2.3. So density of 3.5 density of 3.5 grams per centimeter cube. Let's always put the units because density has units, and whereas this one has a density of 2.3 grams per centimeter cubed. And once again, whenever we are giving differences, you have to give what happens in both areas. Don't come and say diamond is hard, then graphite is not. That is be wrong. Diamond is hard, graphite is soft. Diamond is transparent, graphite is opaque. You don't say diamond is transparent, graphite is not. So is not good. It is a bad thing. I am seeing more hands. Any other? We are having 4 so far. So these are the ones we wanted. So each one of them was carrying a half to make, to make the 2 marks. Then second last examples of we are almost out of time. Examples. Let's have someone to tell us all the examples of amorphous carbon. Louise or Louise. Unmute please. We are out of time.
Coke.
So you can tell me a moment.
Coke.
Color. Yes, we have coke. Secondly,
Coal.
we have coal. Another one.
Lamp black.
We have lamp black. Another one.
Gas carbon.
Gas carbon. I didn't know that one. Okay, we have animal. We have animal charcoal. We have wood charcoal. I'm doing this because of time. What is remaining? We have sugar charcoal. And so on. Okay. And lastly, give one use of amorphous carbon named above. So here you would choose any. You would choose any of the above, any of the above examples. Others were using wood charcoal. It is used for fuel. So someone will say it is used as fuel, and so on. So I'll give only one example here, one answer because of time, but you can check for more. All right, so this was our assessment. If you add up the marks, you can know how many, you can know the total. So here we have 1 2 3 4 5 6 8, then 9, 10, then 12, 14, then lastly 15. So our assessment was out of 15. Okay, so I thank you so much for today, and these questions will be available in our class. They will be available in our class for reference. I still encourage other people that whenever we give an exercise or a test, please let's try to do the test so that we can test ourselves. We can see how far we've gone. Is that right? So that's all for today. Can we have a closing prayer? Kasimo, you can give us a closing prayer. You can tell us what you have to say, then you can give us a closing prayer. He's not talking. Let's have Jovia. Someone is saying that I didn't mark all the work. Some of you sent the work which was not clear. So at times I wouldn't see clearly and I would just leave. I would try to see, but I wouldn't see the work, what you've written clearly. So next time you can write a clear. You can send us clear pictures so that we can read well and mark your work. Let's have a closing prayer. We can have Linda Pretty. Linda Pretty, unmute. Some of you don't want to pray. And God is saying.
Teacher.
Yes, please.
I'm going to give out a closing prayer.
Okay.
Humble yourselves for the prayer. Dear God, we thank you for all our teachers who have been able to teach us. And we thank you for the gift of life. And we thank you for the knowledge that you've given us, so that we be in this lesson, so that we can understand everything we have been through. Yes, in Jesus' name we pray.
Amen. Oh, thank you, Linda. And God bless you. I wish you a nice week, all of you.